Welcome to the Deep Dive. Today, we're going to be taking a deep dive into comets.
Oh, cool.
Those mysterious visitors in the solar system.
Yeah.
You know, based on what we were reading, it seems like a lot of people describe them as like these glowing balls of light.
Right.
With these long, shining tails just kind of flying through space.
I could see that, yeah.
So our mission today is to like figure out what they actually are, why they look so spectacular, and kind of get into all that good stuff. So to start off, what is a comet?
Well, I think one of the most important things to remember is that it's not a star.
Right.
Even though it kind of looks like one.
It's not a big ball of burning gas.
Yeah, exactly. It's totally different than that. It's more like what some people describe as like a dirty snowball.
Oh.
Yeah, so it's this chunk of rock and ice and dust all mixed together.
Okay, so a dirty snowball.
Yeah, and that's why they're so fascinating, right? Because that ice and that dust that's mixed in there can tell us a lot about where they came from and how they formed billions of years ago.
Okay, so where did these dirty snowballs come from?
Well, they definitely don't come from the inner solar system, like where we are.
Yeah.
They come from the really, really cold and distant parts of our solar system, like way out there.
Like way, way out there.
Yeah, we're talking about places like the Kuiper Belt, which is this kind of donut-shaped zone beyond Neptune.
Okay.
And then even farther out than that, there's the Oort cloud. And that's this huge spherical shell that surrounds the whole solar system.
Wow.
Millions or even billions of kilometers from the sun.
So these icy travelers are just out there in the darkness, just chilling.
Pretty much.
Until they start their journey towards the sun.
Right. So what happens is something has to nudge them out of their orbit.
Right.
And that's usually gravity.
Okay.
You know, the gravitational pull of other big planets or even passing stars, it can kind of knock them off course and send them hurtling towards the sun.
That's when things get interesting.
Yeah, that's when the real show begins.
So what happens when our dirty snowball gets closer to the sun?
Well, as it gets closer, it starts to heat up.
Right.
Right? Because the sun's rays are getting stronger.
Obviously.
And all that ice that's in the comet, it starts to vaporize.
Okay.
It goes straight from solid ice to gas. And that process is called sublimation.
Sublimation.
Yeah.
So it's not melting.
No, it's not melting.
It's going straight to gas.
Going straight to gas. And that's what creates...
That's what creates the coma.
The coma.
Yeah, that hazy cloud we see around the comet.
Okay. Then we get to the tails.
Oh, yeah.
Which is probably like the coolest part.
Definitely.
What's interesting is that they can have two tails.
Yeah, that's right. Why is that?
Well, it's because of the sun. The sun's always blowing out this stream of charged particles called the solar wind. Okay. And then there's also the sun's radiation pressure. And all of that pushes on the coma. Okay. So the gas particles in the coma, they get blown back. And they form this long, straight tail. Okay. It's usually kind of bluish in color. And then the dust particles, they also get pushed back, but they're heavier. Yeah. So they form a separate tail that's kind of curved and usually yellowish. So you have two tails, one made of gas and one made of dust.
Wow. And they always point away from the sun.
That's right.
Even if the comet's moving away from the sun.
It doesn't matter which way the comet's going.
Wow.
The tails are always pointing away from the sun.
So it's not like a car trailing exhaust?
No, not at all.
It's more like the sun is actively pushing material off the comet.
Yeah, exactly. It's like it's blowing it away.
So all this activity, like the coma and the tails, that's what makes them visible to us, right?
Yeah, that's right. We see comets because sunlight reflects off all that dust and gas. Okay. And sometimes the gases themselves can glow too. So it's like a combination of reflected sunlight and the comet's own light.
Okay. And some comets can get really bright. Yeah. Like visible to the naked eye.
Yeah, you don't even need a telescope to see them.
Like Halley's Comet.
Oh, yeah, Halley's Comet.
That's like the famous one.
That's the one everyone knows.
Visible every 76 years.
Yeah, it's like clockwork.
So you could potentially see it twice in your lifetime.
You could, if you're lucky.
And because it comes back so regularly, scientists have been able to study it over time. Like really get to know it.
Right. And there are records of Halley's Comet going back centuries.
Wow.
Even ancient civilizations observed it. It's a perfect example of a periodic comet.
So a periodic comet is one that comes back regularly.
Yeah, it has a predictable orbit.
Okay.
And it keeps coming back to the inner solar system. Over and over again.
But not all comets are periodic, right?
No, that's right. Some comets are what we call non-periodic. Okay. They only swing by the sun once, and then they're gone forever.
Wow.
Never to return.
And those probably come from the Oort cloud.
Yeah. Most likely.
Just kind of got knocked in, and they just kept going.
Yeah, one-way trip out of the solar system.
And they probably come in all shapes and sizes.
Oh, yeah, for sure. Some are small, some are huge.
Some are brighter than others.
Exactly. Some are faint, and you need a telescope to see them.
Yeah.
Some are bright enough to see with the naked eye. It just depends on how big they are.
Okay.
How much ice they have and how close they get to the sun.
And how often they visit.
Yeah, exactly.
Every few years. Some every few thousand years.
It's amazing to think about them out there.
Yeah.
Just silently orbiting for billions of years, just waiting for that gravitational nudge to send them on their way.
So just to recap, comets aren't stars.
Nope.
They're these icy, dusty objects.
Yeah.
Left over from the early solar system. Way out there in the Kuiper Belt and the Oort cloud, gravity can pull them in towards the sun.
Right.
Sun heats them up. Ice turns to gas, creates the coma and the tails, which are blown away from the sun by solar wind. We see them because of reflected sunlight, and sometimes their own light. Some are periodic, like Halley's. Some are non-periodic.
Yeah.
Never to return. It's kind of a wild transformation, isn't it?
It is.
From a frozen chunk in the darkness to this dazzling spectacle. It's like they're ancient space travelers.
That's a good way to put it.
Messengers from the edge of the solar system. And they hold clues about the early universe.
They do.
Like what it was made of.
Yeah.
What conditions were like. Billions of years ago.
Exactly.
So what else can we learn from these mysterious visitors? What secrets are they still hiding? What can they tell us about the history and evolution of our solar system? That's something to ponder as we continue to explore the cosmos. Thanks for joining us on The Deep Dive. We'll see you next time.